Okay, we're going to talk about trig ratios today. So what that means is, as we talked about the other day, we are going to start taking angles, remember angles that look like this, and they are going to crash land onto graphs. So as a quick review, we know that we have an x-axis and a y-axis. We know that we have, let me get rid of this for a second. We know we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we talked about what an angle in standard position looks like, and it looks like you have an initial arm on your x-axis and then a terminal arm somewhere else on the graph. So this is called standard position. We also discussed that our angle is referred to as theta, and then the angle that's created between the terminal arm and the nearest x-axis is called a reference angle, and we refer to that as theta r. So knowing that this is on our graph, we're going to look at trig ratios with that. So I'm going to go ahead and I'm going to plot a point here. I'm going to plot a point right here at 5, 3. Okay, so that's graphing. But now I'm going to put an angle that's going to run through my point. So if I put my standard position here, I'm going to have my initial arm, and then I want my terminal arm to run through. Okay, so here's my terminal arm. It's going right through my point that's at 5, 3. So I have a graph and I have an angle. Now I'm going to take this a step further and I am going to create a triangle within my angle. So do you see how what I've done here is created a triangle? So I've had my angle crash land on my graph, and now I'm going to throw a triangle in here. Okay, so this is kind of what this looks like. And this all seems logical, right? Like it all fits together. So let's discuss my triangle here. So let's talk about it in terms of a graph. So if I was to look at the bottom side of the triangle right here, that's in a graph an x value, right? And how many x's? Like what's my x here? It's 5. Right? So like the length of my triangle is 5. And then what if I wanted to look at the height of my triangle in terms of a graph? In terms of a graph, this is a y value. And how tall is it? It's 3. And I know that because remember, I put a point here at 5, 3. Right? So in terms of a graph, that's what it looks like. In terms of a triangle, I have a base and a height, right? Now, what is this part of a triangle called? This part I'm putting in green. This is a hypotenuse, right? This is a hypotenuse, h. And if I know that this is 5 and this is 3, can't I figure out my hypotenuse using Pythagorean theorem? I can. I could say that, we know a squared plus b squared equals c squared. And really, I've got 5 squared plus 3 squared equals c squared. So 25 plus 9 equals c squared. So what's the square root of, what are we working with, 34? So 34 equals c squared. So c is 5.8. Okay, c is 5.8. So this is 5.8. Now, just to be clear, we just said that a squared plus c squared, b squared equals c squared. But how do we have these labeled? We actually have them labeled as x, y, and h. So what we really have is x squared plus y squared equals h squared. Do you see how the Pythagorean theorem I can rewrite using different variables that are a little more descriptive of my angle. Okay, so that's all well and good. Now let's throw another piece into this. If this is a triangle, we know that we can use SOHCAHTOA on it, right? And we know that this is, theta right here, right? The angle that is near the origin of the graph is going to be our theta. So if that's theta, let's think in terms of trig. If this is theta, what is another name for y? Is this side the opposite, the adjacent, or the hypotenuse? It's the opposite, right? And if this is the opposite, then what is this bottom side compared to theta, with respect to theta? It's going to be adjacent. And then, look, we already said that what is this h? It's our hypotenuse. So that's convenient. So all of a sudden here, I can find trig ratios, right? Can I find trig ratios? Can't I find the sine of theta? And I know the sine of theta, remember, is opposite over hypotenuse. So here it would be 3 over 5.8 if I wanted to find the sine of that angle. And what if I wanted to find the cosine of that angle? I would say, well, cosine is adjacent over hypotenuse. So adjacent here is 5 over hypotenuse is 5.8. And then what if I needed to find the tangent, the ratio of the tangent? Tangent's opposite over adjacent. So opposite, remember, was 3, and adjacent was 5, so 3/5. So these are all ratios. Remember, what's the word, another word for ratio? It's really just a fraction, right? Just a fraction. So if you're asked to find a trig ratio, we're just asking you to set up the fraction, right? You don't actually have to divide it. You just need to set up the fraction. Okay, so let me recap how I did this. I had a point that was given. I plotted that point. From that, I created a triangle, and I was able to find the base and the height of the triangle from my coordinates, right? I knew that it was 5, and I knew it was 3 tall. Then we used the Pythagorean theorem to figure out the hypotenuse. Once we had a base, a height, and a hypotenuse, we could rename those as adjacent, opposite, and hypotenuse. Okay? So let's take this a step further. We know SOHCAHTOA. SOHCAHTOA. We know that that means sine. Hold on one second. Okay, we know that typically the sine of theta equals opposite over hypotenuse. But let's come back over here. Let's write that in graphing terms. Opposite on a graph is y. Y. And we're going to hold off on hypotenuse for a second. Cosine theta is adjacent over hypotenuse. And now we know that adjacent in graphing terms is x. In tangent, theta is opposite over adjacent, which is y over x. So all we're doing is taking those trig terms we've always used and replacing them with graphing terms. Now, this hypotenuse situation, let's discuss. We're going to take that to the next level. So right now, we have a triangle. We're going to throw one more wrench into the system. What if we took what we've got here and we're going to draw a circle over it? Okay, so I'm going to take everything we've got and I'm going to draw a circle. Whoops, wow, maybe I should learn how to draw circles. If I draw a circle, let me see if I can make this circle look a little bit better. Okay. If I draw a circle, what now is this hypotenuse? And if we're talking in terms of a circle, what is this hypotenuse? What is that on a circle? It's the radius. It's the radius. And circles are about to become a very important part of our life. So a radius is another term for hypotenuse. So that means I'm going to come over here, and everywhere I had a hypotenuse, this is actually a radius. Okay? So this is worth screenshotting right here. Our traditional trig formula, we can rewrite in terms of graphs and circles with x's, y's, and r's. So there's triangle terminology and there's graphing circle terminology, but they all work together and they're all the same thing. Okay? So let's try another one. Okay, this time we're going to move to a different quadrant, and only if I can find it. Okay, so we're going to move to a different quadrant. Let's say we have a point -4, 5. I lied. -4, 3. Okay. So the first thing we're going to do is we're going to come plot -4, 3. So we're going to say 1, 2, 3, 4, 1, 2, 3. So I'm going to plot my point right here. Okay, so step 1, plot point, right? Plot point, step 1. Step 2, draw standard position. Okay, so we're going to draw a standard position angle. So to do that, I'm going to remember what standard position looks like, and it's over here. And then it's going to angle up this way. Okay, so here's my standard position, and here's theta. All right, here's theta. Okay, now we're going to draw our triangle. Remember, our triangle has to go down to the x-axis. So our triangle is going to go under here. So here I'm going to draw my triangle, and it's under here. Okay, so okay, here's my triangle. Now let's label what we know about our triangle. What is the base of our triangle? Well, it's -4, and the height is 3. So now we need to calculate our hypotenuse. So to do that, so our next step is going to be calculate hypotenuse. Okay, so we're going to do that, and we're going to say 3 squared plus -4 squared equals our hypotenuse squared. So 9 plus 16 equals h squared, so 25 equals h squared, so 5 is our hypotenuse. So now I know that this is 5. Okay, that's my hypotenuse. Now, your hypotenuse, because of this, is always positive. So it's always a positive number. You can't have a negative hypotenuse. You can have a negative x, you can have a negative y, but you cannot have a negative hypotenuse. Okay, so our next step is we're going to label our sides. All right, now this -4 I know is my x, and this 3 is my y, and this 5 is my hypotenuse. I also know that the -4 is also, we're looking right now at the reference angle, right? This triangle is actually built on a reference angle. So that's going to be where we're using our sine and cosine angles off of. So the -4 is our adjacent, right? That's our adjacent. And the 3 is actually our opposite. And what did we say we can also call the hypotenuse? We can call that radius. All right? So if we want to find trig ratios, our next step is to set up ratios. So if we want to set up our trig ratios, all we're going to do is say the sine of theta equals y over r, right? Because that's opposite over hypotenuse. And y over r is 3 over 5. The cosine of theta is x over r, which is negative 4 over 5. And then the tangent, of course, is tangent theta. Tangent is opposite over adjacent. So that's y over x, which is going to be 3 negative 4. Okay, that's all there is to it. Now, if we do this, okay, so wait, time out. Let's back this train up. Here's the steps you took. You said step 1 was plot your point. Step 2, draw the angle in standard position. Step 3, calculate your hypotenuse. Step 4, label your sides. Step 5, set up your ratios. That's all we did. The key to this is being really careful about when you've got different quadrants. So let's do one in quadrant 3. Let's say you were asked to draw an angle in standard position that went through point -4, -2. Well, if you did that, you'd go over 4 and down 2, and you would have an angle in standard position that looked something like this, right? So here's your theta. However, your reference angle, and therefore your triangle, is only in this little piece right here, because your triangle only goes to the x-axis. So again, you've got -4 is your x, -2 is your y, and your hypotenuse you can find is -4 squared plus -2 squared equals your hypotenuse squared. So 16 plus 4 equals h. So h squared. Now you're going to see this a lot too. We're going to stop taking the estimated decimal on your hypotenuse. We're just going to leave that as root 20 because it's an exact answer that way, and if we took it to a decimal, it becomes an estimate, right? So if we have this, and then we go to set up our trig ratios, what's that going to look like? Well, it's going to look like this, and I want you to be careful of this stuff. So sine theta, remember, is opposite over hypotenuse, which we said opposite is really your y, and hypotenuse is now called your radius. So in this case, you have -2 over root 20. Your cosine of theta, and I recognize that we're referring to theta even though we're dealing with the reference angle, which we're going to get to in the next lesson. Okay, is your adjacent over your hypotenuse, which we know adjacent is now called x and hypotenuse is radius. So that's going to be -4 over root 20. And then our tangent, this is the one you have to be careful on, is opposite over adjacent, which is y over x, which is -2 over -4. Now, look really carefully at that guy. What's a negative divided by a negative? Positive. What's 2 divided by 4? Half. Okay? So a negative divided by a negative is going to give you a positive. Don't let that trip you up. Okay, same deal would happen in quadrant 4. if we were asking you to draw an angle that traveled through 3, -5, it would be 1, 2, 3, 1, 2, 3, 4, 5, and you would have this angle down here. Now, the standard form of that, here's your terminal arm, here's your initial arm, which means theta's right here, but your triangle is going to occur here. Okay, so here's your triangle underneath here. And again, you know you've got 3, you've got 3, -5. You can find your hypotenuse. So 3 squared plus -5 squared equals h squared. So 9 plus 25 equals h squared. So the square root of 34 equals h. So root 34. So you can set up your ratios, the sine of theta, the cosine of theta, and the tangent of theta. So opposite, so sine, we said, used to be opposite over hypotenuse. That's now y over r. And we know that that is -5 over root 34. That's our trig ratio. Cosine used to be adjacent over hypotenuse. We now call that x over our radius, which is going to be 3 over root 34. And then tangent, opposite over adjacent, is now y over x, which is -5 over 3. And you're done.